Od razu, zanim zapomnę, zadam to pytanie, o którym zbyt często zapominałem. Are there any only English-speaking people here? There is one. So at least these common places will be held in English. When it comes to the presentations, I think that we have one in English and one in Polish for today. So two in English. We're flexible. Okay, so my name is Kuba Wasielak. I will be your host for today, and I will be telling what will wait for you on the meetup today, what you can expect, and I will be your guide today. We're still at the Pykonik start, which should have started a bit earlier, but I will just make it a bit quicker. In around less than 10 minutes, we're going to have a first presentation by Michał about developer workflow with Docker Compose. At 7:15, there will be a pizza break, and we hope that we think that it will last around half an hour. After that, a second presentation by Sebastian about tests with a very catchy title. And after that, there will be a lightning talks session. Do we have anyone here who doesn't know how lightning talks work? Do we have anyone here who knows how lightning talks works? So I think we have a lot of people who didn't raise their hand at all. So I will just explain.
Do you speak?
Lightning Talks is a great opportunity to stand here on this place and tell about anything that you found interesting or that will be happening interesting in front of the public. It can be something about an interesting library that you've recently been reading about, some kind of framework thing that you found out, or maybe there's another event, Python related, or generally speaking, IT related that you want to present. You get a microphone and the screen for 5 minutes, and this is 5 minutes for you. So if you feel like you would like to tell the rest about something interesting, this can be your 5 minutes. Is there anyone right now who will be interested in giving a lightning talk? 1, 2. Okay, so at least 2. Usually we have more in few hours. There will be a competition, but to that I will get in second. Now, about sponsors. Because these meetings are made by a lot of people, but we want to show some gratitude to our sponsors. The first sponsor for today is Deployed, a well-settled sponsor of a lot Pykonik meetups. Thanks to them, today we will have a snack break. There will be a pizza during that break. There is a water, so if anyone is feeling thirsty, feel free to grab one. And there are some stickers and other souvenirs that you can catch at the entrance. Just one quick word about Deployed. Deployed is a software house in Krakow. It's been engaged to Python community for a very long time. In general, let's just give them a huge applause. The second sponsor for today is JetBrains, another sponsor for years for the Pykonik meetings. Thanks to JetBrains, there is a competition in which there will be 2 prizes. These are 2 1-year-long any JetBrains professional tool. So for example, PyCharm professional, not that I'm going to suggest that you're all writing Python, but I guess you do. So any 2 winners of the competition will gain 2 1-year-long JetBrains professional license. Let's give them an applause. We also have 2 partners. Partners are groups that... Hello. Okay, so how many lightning talks do we have today? Okay, so 3 for now. I guess it will have more. 4. Okay, as I mentioned, the amount of lightning talks usually grows during the meeting. The first partner for today is Krakow's Linux user group. The guys that settled all this equipment, they did it in 15 minutes since they arrived with all those lovely boxes. So I think they really earned a long and loud applause. So thanks for them. And that is also another thing that worth to mention, that I also wanted to welcome everyone who is watching us on the streaming, because all the meetings are streamed, all the presentations are streamed. So there might be people watching us. We will be looking at the comments. So whenever there is a question that anyone would like to ask, feel free to just leave a comment and we will read them out loud to the speakers. Last but not least, Cosmo. Thanks to Cosmo, we have this venue and a lot of things getting around with getting this lovely venue. And yeah, huge applause to them as well. Usually there's a part where sponsors and partners come here and tell a few words about themselves, but today is an odd day, so that's why I'm telling about everyone. Nevertheless, the last thing that I wanted to mention for now is that we have a Discord channel server. If you would like to join, it is discord.pykonik.org. Why it's worth? Because it's a Discord, so it's cool. Because it's a Discord full of developers, which is even better. And it's a Discord full of Python developers from Krakow, which is the greatest. And it's pretty live Discord, so there are a lot of channels that are pretty lively. So if you feel that you would like to connect more with a Python community in Krakow, that's the best place to join. And there's even one more reason to join. There is a Pykonik 62 channel here. If you join that, that's the channel that will handle the competition. And we're going with the old but well checked competition rules. The competition is write something that you've learned during the last month. Write something interesting, a fun fact, probably about programming, but it doesn't have to be about programming, on the Pykonik 62 channel. And the 2 messages with the most reactions overall wins the competition. That's it. I will write a summary of those rules on that channel as well in a few minutes. One important thing, yes, thanks for the note, that competition is only available for those that are here in the room. So, if you're on the streaming, feel free to write something interesting, but to collect the prize, you need to be here in the room with us at the end of the meeting. That's one of the things. Like, we want to keep you here for as long as it's possible to share the knowledge, of course. What else? There was one thing on the agenda that I've missed, the after party. At around 9:15, we're going to Infusia for the after party. Unfortunately, this is also available only to the people in this room, but we can encourage people on the streaming to join us, but we won't stream that part, of course. That's it for today. Does anyone has any questions for now? If not, then I'm passing the microphone to the first speakers. Let's give them 2 minutes to set up, and thanks.
one second. I need to run a timer so I know where I am, because with the questions I can get a bit carried away. Yeah, but that's my ritual. And I also need to have the water because I'm dry as a mummy. Okay, let's, I hope I just don't pour that all over my laptop. Right, yeah, so I guess everybody's ready. If you're ready, then I'm ready. So, hi, I'm Michał Bultrowicz. I guess you could say I'm like a holistic backend developer, Python backend developer, because I write the code, I can do that. I didn't do it all the time in all the places I've worked at, but I can write the tests, I can write the code, I can write the infrastructure code, the metrics, the alerts, and that gives me, I think, a cool perspective of what's needed to really build and deliver working software. So, yeah, nowadays I'm trying to veer off into like end user software, so like just apps for people. But yeah, that's not important right now. What's important right now is that I'm going to be talking about the developer workflow that you can have while working on your code, on your Python code, if you use local tests with Docker Compose. And if anybody's interested, the slides are available at this address. You're gonna find the dev workflow with local Docker Compose tests there, and there's a source code to all the slides. So all the links. There's gonna be a couple of links in the slides, so all the links are there if you wanna check it out. Right. So I would hope that if you're here, you know what Docker is, but I guess we can't bet on that. So who knows what Docker is? Okay, who's used Docker? Okay, it's not bad. So I'm gonna give intro into what's Docker. So it's a technology that enables you to have like a process or a group of processes that are separate from the host's system. It's like a namespace, literally. They have a file system that's separate from the host file system, and it's a bit like a VM, virtual machine, but not really. Oh, and if you use Docker or containers, you're actually always using Linux, because if you have Docker on Windows or Docker on Mac, unless they've changed something in the last year or so, you actually have a VM that runs Linux and has a Linux kernel, because containers are a feature that's only there in the Linux kernel. So yeah, that's a fun fact, I guess. Right, so Docker is an implementation of containers. There's a couple of them, although I've only ever used Docker, but I've heard good things about Podman. I think Red Hat is investing in that. And yeah, and Docker Compose is something that it's another tool written in Python that enables you to describe and manage a group of related containers. Right. So today, most of the examples are gonna focus around this sample application. That's a link, by the way, so you can find all the code there. The application is a simple Python REST API coupled with a Postgres database. It only has 3 endpoints. One enables you to create a new node. Another enables you to retrieve a node by its ID. The third enables you to get all the nodes from your database. Right, so this is everything you need to Dockerize your app. So the details aren't that important, and I know that's quite a bit of code to just throw out there, but you can pinpoint a couple of things. So this is our Docker Compose file, and you define services here. So we have 2 services: the API, which is our Python application, and the database. Both the applications bind some ports so that we can talk to them over the network. Python is going to be bound on 8080, Postgres 5432, which is default Postgres port. Another thing, if you're using Docker Compose, you specify configuration for the applications as environment variables. So our app takes only one, which is the Postgres host, and that host is equal to database. So Compose's networking gives you this nice thing that the names of the containers become hosts on the local Docker Compose network. So API can just do HTTP post to database colon 5432, and it's talking to the other container. By the way, there's something I forgot about. If you have any questions during the presentation, just raise your hand, when you feel like it, and just shout the question at me. I'm going to repeat it into the mic, and hopefully I'll answer. So just bear that in mind. Right, where are we? Configuration. We don't need to pass any more variables here because everything else, all the other Postgres variables are just defaults because the application has some configuration defaults. Another thing of note is that our Postgres container has a volume, and that's gonna enable us to have persistence. Because if we wouldn't have a volume, if we would kill the container and it would get back up again, it won't have any data. And that's not something that you usually want your databases to do. So if we have this, volume, then the data is going to be persisted across restarts. About the Docker file, not much there. We're just basic stuff, copying over the code, installing the requirements. Well, actually, this is copying over the code, and this is running a local HTTP server. It's running UVcorn because the application is using Fast API as the backend framework. And so this means this build target here is going to hook, Compose is going to eat that Docker file. Let's say if we say to GitHub, it's going to build that Docker file as well. And we don't need to build Postgres because we're just using a well-defined image. Right. You might notice I'm using make files. I know that some people don't like make files, but in general, what I recommend is that you have a single centralized file, like a script file, that has all your development operations, whether it's like running the application, running the tests. It should all be defined in a single file. So you don't have like disparate doc files or whatever, or people wondering how do I actually work with this application. It's all in this one file. And also Makefile has this nice property that it runs on pretty much everything. It's on the servers. I think you can run it on Windows. I know some people do. And it gives you tab completions, so you don't need to type the entire target. If you want to run something, you just do make S, and if you press tab, then it will show me setup development, if you have tab completions set up properly, which isn't the problem in like modern shells, so use ZSH. Yes? Right, so the question is, what's the benefit of putting the explicit shell declaration? So make is a bit of a bastard, and it's not going to give you the shell you think you're going to get. So most often, you have your bash, and everybody's pretty much used to bash, but make will use shell, which is older, and it works weirder. So bash nowadays, it's everywhere. So let's just, I guess the lowest common denominator can be bash, and it's useful to have that explicitly. I've wasted hours or days of my life in total over weird shell issues in make files. Yeah, don't let your make files grow too large. They're not a good place to maintain code. Yeah, that's why you have the shell declaration. Okay, other main commands: setup development, which just installs all our Python development tools. I'm using Poetry there. That's gonna create a nice local virtual environment if you have like one flag set up. And then there's run, which is going to start Docker Compose and run the database migrations. And these are like sub commands with like run target has two sub targets: start compose, db migration. They're defined here. So you see, makefile enables you to compose commands together. And one note about migrations in this Docker setup, you will have to inject some weighting into them. It's usually simple because migrations are just Python code, but because we do start compose and then immediately try to run migrations, Postgres is going to take a few moments to get up. You might start your migrations before Postgres is actually responding, and that would just crash. So you just, whatever framework you're using, you can inject sleeps or, awaiting in the migration so that they're wait and this thing works nicely. So with that, if I would give you that repo and we have somebody new on the team, and I just tell them to run those three commands, and they might have a clean environment. Okay, they need to have Python, they need to have poetry, so it's not entirely clean, but it's pretty clean. Anyway, if they run this, they have a working local application. They can play with it. They can modify the code, observe how it behaves. They can talk to the database, see the data that's getting returned through the application. So I think that's pretty sweet. I've noticed that a lot of teams neglect that ability to experiment locally, and it goes bad over time. I think if you have that ability to play with it locally, it's going to save you a lot of time in the long run, and it's going to improve quality dramatically. Also, you have very simple documentation of how to run the application. It's not like install this, install that, and do all sorts of weird steps that go out of sync over time. Excuse me. Right, time to actually have some tests. I'm going to show you two examples of kinds of tests that aren't unit tests, because a lot of times when people think about testing, it's unit testing. Integrated tests aren't unit tests. You might, they get referred to by different names. You might hear integration test. I don't feel very strong about it, but I prefer integrated because it implies that the test is integrated with something. It's not testing integration of things, because you can test integration of like 5 applications together, and that's not what an integrated test is. Integrated test checks your internal interfaces, so like a class or a function that connects to an external system. In our case, Postgres in the container. You can see a simple integrated test here, which is, create an object which is a string with a bit of randomness, and that randomness comes in handy with these kinds of tests to be able to differentiate between different things in the database. Excuse me. We create an object which is just a repository pattern object. So this object is going to be responsible for talking to the database and actually storing objects, retrieving objects. Right, that's our range part of the test. The acting is just, just running a function. Create me the node with this string contents. And this will actually, from our test, from our Python test that's running outside of containers, it's just running in our standard system. That's going to call out to Postgres and do stuff, actually write something to the database. And then the test code also calls out to the database, because it can, to verify that something happened on the database. With that, we don't need mocks. Sometimes we will do, but we don't need mocks to check code that's talking to the database or talking to the queue or stuff like that. Of course, to have like a full certainty that the nodes repository object is going to work, you will need more tests. But after you add your tests for the rest of the methods, then you can be pretty certain that nodes repository works correctly. Like you have proof that it's talking to Postgres and it works. So after that, you might in your unit tests, take nodes repository and replace it with some mocks, or replace it with an object that inherits from nodes repository, and and doesn't call the database, so that you have faster tests. The second kind of test I would like to mention are, well, I call them external tests, but it's not a name that I've found in literature. It came up in one of the companies I worked at. We were talking about functional tests or end-to-end tests of the application, but it wasn't very clear what we mean by them. So external means that the test is talking to the app from the outside. The test is external to the application. It doesn't use any internal interfaces of the code. It doesn't use, well, you can use some of the application code for like utility stuff or whatever, but you should minimize the use of your application code in your external tests. Also, it would be nice if the configuration of the app that you're running the test against is as close to production as possible, because that gives you more certainty that things are actually going to work. And with our simple Docker app, like we could just take that image and put it in production. It would behave the same if we would attach like AWS Postgres. So here we are running the production config because the application doesn't know it's not in production. It's just running in a container. Right. One warning about them though, they are harder to debug because it's not like you can just drop in a debugger. With some tools you can, but by default, your tests are a completely separate process from the application there. You're not going to get a stack trace. You might get error logs in the container, which you will have to read during a test like that, but you won't just get a nice stack trace. Right. But let's get into the meat of the test though. You might notice that they look a bit like user acceptance tests, if you know what that is, because you can only use the interfaces that the application is explicitly enabling to the outside world. So, for example, if I store a node, I could believe the application that it did store it, but it's better to test the application that it actually did store it. And how do I test that the application really stored it? I ask the application again, give me that node that you gave me before. And that bit of randomness helps us prevent any false positives, because I could just write the implementation that would return string AAA, and if my test would just, file node AAA, then, we could get a false positive, but, those bits of randomness prevent any false positives. So what happens here? This test actually calls out to the application in the container, gets the result, then tries it again, give me that node that I just saved. Okay, that's fine. And just to be a bit more interesting, we also get all the nodes and look through the entire collection that we've received and see that our node is actually there. What you might notice here is that, a lot of times when you're testing and you're testing for like, returning some collection, in unit tests, you should always know what the collection is going to be. Here, you can't know what the collection is going to be because the system is sort of live. It's like a small local deployment. So, the tests can't know what other tests ran before and put stuff in the database. So that's something to be mindful about when you're structuring your tests. Some code that's missing from the previous slide. That's a bit of PyTest trickery, because you see that test uses an app URL parameter. It's actually a PyTest fixture, which is session scope. What does that fixture do? Well, it actually just returns the string. That's the address of the local application. But before it returns, it waits for the application to get up. It uses tenacity to basically do retries. So we just try to ping the local container until it successfully returns from a basic HTTP call. If it doesn't return in time, we're gonna raise an error and we know we have some failure and we need to investigate container logs probably. Yeah, and one other thing to note here is that we're using session scope. That's gonna ensure that this thing is only going to run once per the entire test suite. So, you know, we don't need to wait every test, for example. Right, running the test requires, well, it doesn't really require, but we might add some more stuff to the make file for it. I recommend having a single command that does all of your validation. So all of the static checks, running the tests, it's all just one command. You know, you do make check and you know that the thing should be working. Of course, you can compose those commands. So, you know, we have static checks that does a couple of different things. Each of that is a separate command. Sorry.
Could we get back to the previous slide?
Yep, yep.
Two questions actually. What does this monkey sign mean? I don't remember.
You mean this? Right. So the question is, what does that mean? Excuse me. That just means that make won't echo the command, because by default make echoes all of the commands. If you put that on the first character of the line, it's going to skip the echo because I'm making the echoes explicit. And you know, putting dashes is useful if you have like a bunch of commands that just run in sequence and you know you want to visually distinguish where the output from one command ends and another begins. So that's just like a useful little aesthetic tool. Right. With those two kinds of tests, we get something that we would never get from a unit test. Like no matter how many unit tests we'll write, we'll never know if the app actually turns on. And I actually had, you know, a lot of issues like that years ago that, you know, we had like high test coverage, but we would deploy the application, luckily to the development environment, and it would just crash because, you know, somebody messed up something about the config, something about container definition, something like that. But here, you know, we have concrete proof that the container is building and it's working because it's actually, you know, returning responses for our requests. The calls actually go through all the layers of the application and return to us. So yeah, that gives us higher confidence. We can never be sure that the application is working in the general case, but we can be more confident that it's working, and that's a lot. And you might notice that, you know, I haven't used any mocks here. It's quite fast to write these kinds of tests without mocks. And they also help you get high coverage and all that stuff. Right, but another cool thing that they give us over unit test is the freedom to use the tools that we want. Because oftentimes, you know, when you write unit tests, for example, with Django or like some other standard web framework, like we don't actually talk to the database, and we can only use the features of the database that the framework supports, which is often very limiting because there are things you can do at the data layer that's gonna like cut down development time by a lot. It's gonna usually, you can do tricks in the data layer, for example, in the database, that are going to be way faster, more efficient, and faster, more efficient, and just sometimes aren't available in your backend code. Like there are things, there are certain certain properties that you can only get in the data layer, for example, and never in the application that's talking to the database. So if you can actually test anything about the database, like you can test database triggers. You know, you don't need to write as much Python code, you can write more SQL, but you can have very tested SQL, which is nice. They're generally they're slower than unit tests, integrated and external tests. But if your app is fast, then they will be pretty fast. But sometimes they pull the rug from under people because there's no test isolation. Usually, like traditional knowledge says that all your tests should be isolated. We don't get that here. So we have a bit of chaos. Like if you want to reset the database every test, let's say, with something like Redis, I actually done it and it's possible, but you basically that stops you from using any test parallelization, because if a bunch of tests run independently and they're like cleaning the data and using the data, that's not going to work. And if you try that, cleaning with SQL, that might be a bit slow. So yeah, we don't reset the data; it just lives. And some tests, like getting all the nodes, will have to accommodate that fact that we don't have isolation, where we can have like random junk there, and also like that local database and local app just running there and the data gathering over time, that might give you like weird issues. But with that bit of chaos comes more realism. Like if you deploy a web application in reality, like if you have like a web store or something, it's not going to be resetting its data every second call. Like that never happens. So tests should work on a model of reality, of the real application, and having that bit of chaos is more real. A lot of times, I was bugged by some like weird thing happening to my app after I do this change locally, only to like spend 3 hours on that, and shit, I'm like late on delivery on that feature, but hey, I've actually found the bug before it went into production. Because usually, it could go into dev and then be caught there, but dev is quite sterile a lot of time as well. I also like to have messy devs, by the way. So yeah, having that messiness locally enables you to find the bugs quickly. Also, if you have like integrated tests that are a bit more asynchronous, and these are fun, like write something to the queue, wait for the queue to get back and whatever, and those tests are flaky for some reason. Like sometimes they pass, sometimes they fail. A lot of times when I had issues like that, I actually found bugs. So if your tests find bugs, they are good tests. Right, so you fix more bugs, you increase the quality. But if you have problems with like the local database and you just don't have the time to deal with it, then just do docker compose down -v, and that's gonna wipe the volumes as well. So you're gonna start with clean data. How do I separate the tests? I just have my test folder, which explicitly says these are external, internal, and unit tests. It's good to be mindful about what test is what, because you have different expectations about them, and you shouldn't just start doing everything as an external test, because they have upsides, but they're also like harder to debug. They are slower, so just be mindful. They're a good tool, but don't overuse it. But one cool thing, if you have that separation with PyTest or pretty much whatever testing tool, you can run subsets easily. Just PyTest unit, and I run only unit tests. And if you want to know more stuff about what I think about these tests, there's an article here underneath that link. Right. So nobody has any questions so far? Okay. So yeah, our application is very dumb and simple, but I can tell you that I've did variations of those techniques in 3 companies, and there seems to be no fundamental problem with them. Like they were working. Usually my apps were of the like higher end in terms of quality and reliability, so it seems to be fine. Like whatever whatever tool has a Docker image, like you can integrate it with your app, and it's actually a part of your application. So you can write less code and rely on like services and databases and just tools more. Couple tips: if you're using something like AWS and you're relying on like S3 or whatever, there's a tool that you can run as a container that's called local stack, and it just mimics, it fakes AWS services. There are some like simulators for Google Cloud and Azure, but I don't think they're as featureful. Also, if you want to fake out an entire other application as part of your test suite, if it's a REST API, there's this tool called Mountebank, which you can configure with HTTP to respond with HTTP. So it's like a faker of REST APIs, and I actually have a library to manage that in Python. By the way, the docs are very outdated. Use external Mountebank class if you ever get to using it. Right. Another very cool tool that I don't see people use enough is the ability to reload your code quickly, because normally if you want to put code in the container, you need to build the image, you need to run the image again, but there's a shortcut that you can take to just have the up-to-date code hooked, like mounted in the container all the time. I usually set that up in another file, Docker Compose override YML. That's automatically getting merged with your basic Docker Compose file. What I said there is, I add a volume for our API container that just mounts my local directory with the code package to the place that that package is located in the image, in the container. So if you have that, your applications your container is always going to run with the most up-to-date code. But you still need to, like, if you change the file, you still need to restart the container to make the changes take effect. So you could, right. So we need something that's going to reload the container on code changes. Like, that's pretty sweet that you just save the file and the container changes. You could do that with some like framework tools. Pretty much all the backend frameworks have some tool to just watch the code and reload the application when it changes. But there's also a universal tool called Enter. You basically just pipe a list of files into Enter, because FD is like a better find. So this finds all the Python files in my application's code and pipes that to Enter. Then Enter is going to start watching those files for changes, and it will tell make to restart the container when that happens. So you can marry that with tests that run on file changes. So you just add the code and you have the tests running, and you don't need to like click anything to run the test. You just have feedback, constant feedback. And to have that working, I've actually added that application wait is just so this is going to work. Because if you would save the file with the code, Enter would reload it, the tests would run, but the tests would run before the application managed to get up. So that's why we have that waiting for the application in the tests. So, FD and Enter, very cool tools. Righty, that's it for local development. Now let's get on to the CI, which is the server that, you should have code validation that happens independently of anyone's personal laptop, just to make sure that there's no weird thing happening. And I advise you to remove that Docker Compose override file when you start a CI run. Why is that? because theoretically you could build Docker images without any code, and the volume would just make it work magically, because you only run it locally with the mount, you wouldn't notice that you're missing your code. So that's why I like to keep the override files minimal, and I just delete them in the CI run at the beginning. CI should use the same makefile that the developers use, or your script file if you don't use makefile. Although I wouldn't use make check, because this is just going to give you like a wall of output, and also on the first error it's going to fail, and you might want like more information about what succeeded, what failed. So most modern CI/CD tools enable you to define steps, and you can have a bunch of parallel steps that run your tests, all of the static checks separately, and then you see individually which ones failed and which ones didn't. In the case of an application like that, if you run your tests, the tests are going to build an image, a Docker image. You should, if the tests pass, you should tag that image, push that into a repo, like your company's Docker image repository, and use that in deployment. Don't rebuild images on every deployment, for example. That might lead to bad outcomes, because you might think you have fully repeatable builds, but sometimes you don't. Or sometimes somebody pushes like a image to Docker Hub, and they use the same version even though it's a different thing. So just build your images once and just keep them. Right. One more caveat: if you're using something like self-hosted GitLab CI with like a simple runner that just runs a sub-process for every test run, you might need to think about free ports. Earlier, I hard-coded the ports, so like the API is always running on 8080. If you have that kind of a CI setup, like that simple self-hosted GitLab CI setup, and two developers would push two feature branches at the same time, they would both run the same Docker compose, you would get, like two separate asks for the same 8080 port and two separate asks for the same 5432 port, which, one of them is going to fail. So you don't want that. There's this simple mechanism in Docker Compose that enables you to have default values, but take stuff from the environment variables if they're present. So here, if I would change Docker Compose to look like that, our local tests don't need to do anything else because they're still using the default 8080. But if we want to, the CI can inject that port. By the way, this is the best way that I found on the internet on Linux to find a free port. Something from Stack Exchange. It's actually a small Python script. And that's how you would use it, to just get free ports and get going. Right. There were more things on the agenda, but yeah, I didn't manage to prepare them, and I'm almost at the 40-minute mark. So yeah, debugging code in containers, you can attach to the Docker image and just run like simple Python PDB debugger, like command line debugger. You can do that. But there are also tools like, if you use something like PyCharm, you can have remote Python interpreters in Docker Compose, and you can use that to hook into the application that's running in your Docker Compose, and you can have like your normal IDE debugging with breakpoints and stuff. Yeah, about changes to production code for improved testability, I think it's okay to change your production code so that it's more testable. If you have something tricky to test and the code isn't just yielding to testing, maybe add like another endpoint that's going to help with testing. I think that's fine in certain contexts. So, it's not haram or anything. Right. That's it, I guess, unless you have any questions. Okay, so the question is, what do you think about running external tests against the development environment? And I think that's actually like that's very good. With a test set up like that, I didn't really get to that, but you can use the same test and just, configure the endpoints and just run them against a developed, against a deployed environment, because, they treat the application like a black box. Give me the database, give me the application. You can just point them at any deployment and run those tests. And yes, I think that, that should be done. I also think that testing in production should be part of your monitoring. So, you could take tests like that, have like a test organization or test users, whatever. If you need credit cards to set that up, do that. You're gonna save more money than if you have bugs. But yeah, that's something that's the way to go. Yes.
Yep. That one. Okay. So first of all, thanks for the talk. I learned a bit or two. My question is, do you know any modern guide to Makefile? Because it's intimidating, to be honest.
Yes.
Yeah.
I don't know, don't use a lot of it. Just have build one Makefile once and don't build any logic into it. If you need more logic, have scripts and run scripts. I did run more elaborate Makefile functions, and they were horrible. So just use it to aggregate all the knowledge and have entry points and composition of commands, I would say.
There was one question from the stream. I mean, more like comment. Since V2, Docker Compose is written completely in Golang and integrated in the
Okay,
Docker.
so apparently I lived under the rock too much and didn't notice that. Really, they rewrote that? Oh, but
yes, it's now implemented into the Docker itself. You put Docker Compose without a hyphen but a space. It's inside the Docker itself.
Yeah, didn't know that. It's fun.
Hi. I have one question regarding the Makefile.
Yep.
Is there any specific reason you didn't want to run those Alembic migrations inside of a container?
That they didn't want to run migrations when?
Database migrations inside of a container?
You can do that. I did do that at one point. All of your tests and your migrations could live in a container. You could also just stick it all in your main application image. It's going to grow a bit, but Python images are usually big anyway. So yeah, there's the only reason why I keep them outside of the container is just it's easier to debug. I just, I have my local virtual env. It's faster to run. That's the only reason. And if you have an entire team of Python people, then they usually have Python tools. When we had a team where people weren't expected to know Python, but were expected to run those things, then yeah, I would put the migrations and the tests in a container. Ideally, it would be a separate image that uses the base image. But, if you're short on time, just stick it all in one image. You're gonna save, a couple of megs?
Thanks.
Questions? All right. 3, 2, 1. Thank you for your presentation. As I promised, we are on schedule in the end, but the pizza delivery is not on the schedule. Nevertheless, we'll start a break soon after I finish talking about a few next minutes, and we'll just wait for them. Hopefully they will arrive quite soon, because they should be here exactly. So maybe they will be punctual. We'll see. Nevertheless, we'll have around 30 minutes break from the moment when the pizza arrives. Do not rush you, because we also know and understand that these meetings are not only about getting knowledge, but also about socializing. So feel free to, during that break, to come to the other people, approach the people that you don't know, ask what they're doing, why they're here. There are a lot of conversation starters here. We have a common passion, so it shouldn't be hard to start to getting know each other. After that, we'll have another presentation by Sebastian, and I wanted to remind that we have a lightning talk sessions followed by that this presentation will be followed by the lightning talks session, and there is still a competition running on Discord on the channel Pykonik 62. I also wanted to ask, who of you thinks that we'll be going to Infusia for to chat a bit more about Python and to get people a bit more? Please raise your hand. Okay, it's already pretty good. I have a long tradition of asking that question whenever it's possible, and usually this amount grows by 50%. So I hope that by the end of the meeting, it will be at least half of you that would go to Infusia to chat a bit more about Python and to get to know people. For now, thanks everyone. We'll be breaking the stream, and let's start a break and see you each in hopefully half an hour. after the short snack break, there's a bit of echo. Let me move somewhere here. Yeah? It's better now? Oh. That should be better now. Yes, it's good now. After the short snack break, let's start the second part of the meetup, the second presentation. Just wanted to remind that after that there will be lightning talks. Who knows that we'll be doing a lightning talk? There were more people, but yeah, I see. So there is a message on Discord on Pykonik 62, or will be there in a minute. If you have your slides accessible over the internet, if you even have slides, please do whatever the message says, probably sending them over to Piotr, because that would enable us for an easier setup later on. So you don't need to have your own equipment. If you want to just show one static page, one static presentation, just feel free to send it over and we will handle the rest so that you can just tell about an interesting thing. And after that, I wanted to remind that we're going to Infusia to talk a bit more about Python. I wanted to just mention one more thing about Infusia. It's literally less than 100 meters from here. So if you feel not convinced to coming because you're tired or your legs hurt or anything, it's not a reason. It's a bad reason. So you can't use that excuse. So who wants to go to Infusia to chat a bit? I can see a bit more hands. We'll get back to that one. For now, I'm passing the microphone to Sebastian to talk a bit about code coverage and stuff.
Okay.
Let's welcome.
Okay, so hi. Sorry for my bad English. So I got an information right before the meetup that we may need to have a only English speaker, so I quickly rewrote the slides in English, but it should be just fine. Unfortunately, some of the jokes couldn't be translated. I'm sure you'll see how. Okay, so you didn't want to ask Michał questions during his talk, so I will be asking questions you during this presentation. Consider this a punishment. And now, do we have anyone born after year 2000? Okay, there are a few folks. Dominic, I think you're lying. I don't think that was an honest answer. Also, please don't answer the next question. Do you know what's that?
Yes.
Okay. I will check this in 10 years, and I wonder what the answers will be. So, to be precise, this is a T22P Yelling VoIP telephone. You may, associate with, I don't know, office work in the 90s or whatsoever. Unfortunately, or maybe fortunately, it was a tool in my first IT job, as important as a computer or a keyboard or a mouse, because we were doing stuff that was like scripting, telephone exchanges, writing scripts, interactive were hotlines called IVRs. For example, you call a number and you hear in your headset, please press 1 to wait indefinitely for someone to answer your call. And the work looked like this, that I had 2 monitors with a bunch of terminals opened with logs streaming from a few applications at once. And when I made a change, I reloaded some of these applications, pick up the phone, entered the number, and waited either for hearing some friendly message or maybe an exception, as you can see on one of those screens. So as you may imagine, this was pretty tedious and error prone. But of course, when you made a change, yeah? Sorry? No. I have never thought about this, but that's a good one. You know, I still have a friend that works in that company. I will sell that idea to them. Thanks. Okay, that was good. Yeah. So the question was, did I hear an exception over the phone in case the recording didn't catch it? Yeah. So the thing was that it was pretty tedious and error prone. We never know if we test enough, and it took a lot of time. So it's a huge shift
if you manage to automate some of this process, especially if you like able to come up with a nice DSL, which is an acronym for domain-specific language, meaning some code that, you know, looks naturally in the same language of your problem or maybe the thing you try to test. Okay, we need a technical break for a second because that's going to be a problem. Okay. Yep. Okay, so sorry, I got the feedback that the color was wrong. Yeah, so it's a huge shift when you move from testing things manually to like writing automated tests, especially in a language, you know, resembles the thing you're trying to do. Instead of calling a phone that you need to set up first, you could, for example, have like some handful functions that could, provide like very concise look and be just pleasant to use. Of course, the dragons live under the hood, under those functions, but at least the tests are nice. But the question remains whether we are writing enough tests, even if we have them automated. And chances may be that at some point you heard about the code coverage. Who knows it? What code coverage is? Okay, a few hands like laying down, so I will explain it using an example that's close to the heart of people that turned 30 recently, namely a queue to doctor. So let's consider there is a queue to doctors, and there's a function that will return your position in the queue, and initially you will be placed just at the end of the queue. Well, that's simple. But it turns out that in Poland, there is a law that there are certain group of patients that can enter the doctor's room without waiting in a queue. And for example, these are pregnant persons or regular blood donors and so on and so forth. And if you belong to one of this group, you will just enter by skipping the queue. And yeah, in the end, like we return your position from this function. And if we would like to test this function, like we could write a code like this, that we start with an empty queue. We'll create some patient that belongs to neither of these privileged groups. We'll call the function, and we'll check that, of course, the queue was empty, so your position is like 0. So we were the first. And if we add a PyTest plugin called pytest-conf and run the pytest command with --conf and the source code, plus adding another argument --conf -report equals to term -missing, then you will see that some of these lines were not covered by the tests. So, you wrote a test, you checked something, but it's incomplete, of course. And it sounds great, does it? Unfortunately, that's marketing, of course. That's reality. And that's the city of which I traveled from today for you. By the way, this hotel really exists. The chimneys over there still exist. It will be very hard to, demolish them because a new handy apartments of 20 meters have been built all around. So I'm very interested when they will disappear from the landscape. But the hotel got renovated. It looks much better now. So, speaking of which, I'm Sebastian Buczyński. I work as a trainer and consultant for Bottega IT Minds. Like I do trainings from testing, architecture, domain-driven design, and so on. At the same time, I work as a tech lead at Sauce Labs to not, lose touch with the reality. So everything I show you in this presentation, these are things I used, I learned over time that work for me, and so on. I'm here today, and I travel almost 300 kilometers because I have a mission to, dispel some bad myths in the community. Teach about software engineering because many of these issues, with testing, strategies, and so on, has been already solved in many other programming languages. We need sometimes just to adapt, and that's fine. If you'd be interested in more stuff I wrote, I have a Substack account, but this link doesn't work for now, so you will see at the end of the presentation another one. personally, if someone asked me if I would rather live in one universe, if Captain America, Black Widow, and Hawkeye, I would rather live with Bogdan Bonner, the Exorcist, and devils visiting Earth for a smoke, because smoking is forbidden in hell. So yeah. And in the spare time I have left, I'm a bit of an apprentice of alternative coffee brewing methods, just learning the game. Okay, but going back to the code coverage, around 8 years ago, I think, I was the guy that heard about code coverage. I was like, wow, this is gonna be good. We better use it and set it to 100%, right? But unfortunately, or maybe fortunately, the God hands saved me for a moment at least, because I work with a pretty legacy code. So like, it's not easy to not only measure, but also to like enforce a high level of code coverage, because it's like, well, ridiculously low. And sorry, even though I was like, excited 20 years old something guy, I wasn't able to make it like through the night. But unfortunately, or maybe fortunately, sometime later, there was an opportunity, because for some reasons we decided to rewrite from scratch one of the projects. And it was such a moderate size that could be rewritten in more or less 2 weeks. Yes, that was my chance to use a 100% code coverage here. And to tell you maybe 2 words about how this project worked, well, it was the project where it was an application that was not like a typical web application, Django or something. It was, something we call the daemon. This was like something that worked in an infinite loop. It checked database every few seconds, did some calculations, and depending on the result of these calculations, it put the files in a directory. And they were later picked up by another application, but that's, well, irrelevant, what was in these files and whatever. Yeah, so, well, it's not that complicated. Sounds pretty reasonable. And I was like, and then I, of course, used that idea of getting to 100% code coverage. It went pretty well. I was able to get to like 80, 90 something % without any extra effort. But at some point, I died internally. Because code coverage said to me, and this is like very similar to what I saw then, there was some, well, property function, and it said, dude, you don't have a coverage here. What did I know? The remaining tests I wrote like just didn't cover that line. So what I did, well, I wrote just something, a nonsense test that, just instantiated that class, called this method, and asserted that the result is 42. And I never, not never, but for a few years, I never returned to the idea of 100% code coverage then again. And judging from some smiles and laughs in the room, I presume that some of you have similar experiences. Who also had this moment in their career? Okay, yeah. You don't have to raise your eyes. Don't worry. Okay, yeah. So not only in this group, but also like I talked with a few people before, like actually creating this presentation, and this is pretty much well, maybe not common experience like 100%, but some people that try to achieve 100% code coverage at some point without any additional steps I will talk about in a minute, well, had this experience of like writing tests that like pretty much bring no value. So like maybe empty asserts, like nonsense, like assert true, of course this will always pass, or maybe writing a test that doesn't have any assertions, but it just executes the code. So yeah, the coverage is there. And if you look closely at it, especially that when we had this bad experience, code coverage is actually not that great, actually. So, for example, when you write such a test, just this one, for the function you saw in the previous slides, like, again, you have an empty queue, you have a patient that now is like belonging to one of those privileged groups, you run the function and you assert the queue position is 0. Guess what code coverage you get out of that, the single test? 100%. Yay! Does it look like exhaustive testing to you? Okay, someone is, turning their head around. So I guess no. Do you have any ideas for any other test cases that like might be worthy to check? Yeah, go ahead, Michał.
Know if that
Yeah, that's one of the techniques that would break this. Okay, so Michał mentioned the branch level code coverage, which basically checks, well, it's more strict because it checks if all the possible paths of the function would be crossed. So with that option enabled, yes, this will show that, dude, you didn't check, you didn't have a case for a scenario when a patient is not like one of those privileged groups. So let's assume we have those two tests, the one that you see now and the one for some person that's not pregnant, neither a regular blood donor. Does it sound like an exhaustive test suite to you now with those two tests? Who gives more? What? Okay, so there was a voice from the room that you can test all possible cases. Like you can or you can't. Okay. Okay. I mean every. Sorry, come again. Once again. Yeah. Okay. So there is an idea that to check if the patient is potato. I don't know how to comment on that because no one has ever raised this issue. But the thing is that, like, imagine you ask this question to a tester. You know, the one that goes to Infusia and orders -10 beers. And they will start thinking, what if in a queue there's already a pregnant person? And if another pregnant person comes, who enters then? Yeah. What if there are already like 4 pregnant persons in a queue, and there comes another one that's pregnant, but at the same time is a regular blood donor? Who comes first then? Yeah. By the way, do you know what does this legal act say about this situation when, well, several privileged persons come to the doctor? Nothing. Exactly. Nothing. On the other hand, I haven't heard about, you know, battles at the doctor's room of pregnant persons fighting for the who's going first. So perhaps it doesn't happen too often. And an expert, namely a medicine student, told me that probably they need to agree on something. That sounds reasonable. So to sum up, maybe, well, at this point, it looks like that maybe code coverage doesn't bring us a lot of benefits, but at least it needs a lot of meaningless effort, right? And you will end up with an idea that maybe just a Yeti doesn't exist, really. There is no such a thing. And even though like this was my, well, assumption some time ago, today I have this another argument that makes my tests suite fail if the coverage isn't 100%, and it's set both locally on my computer and also in continuous integration. So not only I'm punishing myself, but also I'm punishing my teammates. Yeah, and they like it. That's the best part. Honestly, I haven't asked them if they like it, but I will after this presentation. Yeah, so one of the reasons I'm doing it is that I really like new toys. I really like to stay up to date with the latest libraries versions that bring new features and new bugs. But, well, nothing comes for free. And also in the newest Python versions that, you know, bring new features also, and like recent versions bring performance improvements, which, for example, in my current work are pretty welcomed. Also, I really like to have an option to save refactor. Also, this is thanking to, well, testing strategy. So in the previous talk, Michał was sharing, well, his testing strategy with the various types of tests. So the testing strategy is basically like which types of tests you write, like how they come together and so on and so forth. And I will show you this in a few slides. And the other thing is also code coverage gives me hints during development process, because when I write some code and I have a coverage, but at some parts that I just wrote, I don't, that's the next thing that I will be doing. I will also show some examples so, you know, it will all come together. Yeah, but the thing with code coverage is that, you know, some of you might be unconvinced. Maybe you are stuck in the past with those, well, bad taste in your mouth when it hurts your, well, maybe not feelings, but hurt your productivity or forced you to do things that didn't make any sense. And it gets worse if it wasn't your idea, but maybe some, out of touch manager thought that, getting to 100% coverage might be a good idea, and I won't help my team to get to it. Yeah. I don't know why those people are gone now. Yeah, so for some of you maybe are familiar with Goodhart's law. Who is? Yeah, one person. So, well, it's not a literal quote, but one of the conclusions of them sounds pretty similar. So it's not that, I come to this Pykonik meetup, I'll tell you, do 100% code coverage, and you can just, pick it up, set in your pipeline, and it will just work for you. Absolutely no. The code coverage is rather a measure of how you are doing right now. Your current development process gives you a certain level of coverage. Maybe it's 80%, maybe it's 90%, maybe it's 100 or whatever. But it's just a measure of how you're doing. So you can't improve really on code coverage without changing the way you work. And if it's not true, you don't get the chance to improve the way you work, cheating starts. So, of course, pragma no cover, comment to, just ignore this line. Please don't check coverage on that. And surprisingly, when something blows up in production, one of those lines. Second well approach, I showed assert true or no assertions at all. And the last line, I'm afraid it doesn't appear. I mean, it's not visible that, but you can use this free argument if operator, yeah? That value true, if condition, and else, and then value if the statement is false. So even branch coverage doesn't catch that. So you can cheat. You can actually cheat. I could rewrite those doctor function in a way that it would still have 100 coverage. Hey, how's my time actually? How many times I have left? Okay, because I'm in the middle. Okay, but the thing is that improving the process is the hard part. It's not that, improving the process doesn't come up to, Scrum Master making a retrospective every 2 weeks and asking, what will you do next 2 weeks so, we program faster. No, to improve the process, you need the time to reflection, you need a Slack, and I don't mean the communicator. I mean, the time to poke around, do nothing, get inspired, do some experiments. That's Slack. I don't know why they named the communicator in work using that name. And only that, if you have a chance to, to learn something new, to try it out, how it works out in your context, you can actually improve the process. So the thing I'm going to share with you is like a process for getting helpful 100% code coverage. That doesn't mean writing tests that bring no value, and doesn't also include too much effort. But it comes, there are some strings attached. Namely, you need to possess a couple of skills. First of them is vertical slicing. So when you get a big feature to deliver, you need to be able to somehow decompose it, but in a special way that you can, for example, deliver one part like after, a day of work, maybe 2, then another part after 2 days, and so on and so forth. So you work in short cycles. Everything goes to production very often. It doesn't have to be released to users, but at least, you push it out of the door. Yeah. So the code is already there in production. And the act of being able to decompose the problem is actually the most important. I will show you an example. Let's say we have a system that will be aggregator for various shops, and you will be pulling offers from many vendors, and later you will present them on a site in combined form, and someone will be able to choose a few of them and buy them. How do we approach slicing of that feature? So traditional, maybe not traditional, but the anti-pattern is to use horizontal slicing. So okay, first of all, we build, the foundation. Let's integrate with vendor's API. Then you create a backend service on top of it. So, there is an API so we can browse offers and buy stuff. And at the end, too fast. At the end, you, build a front end on top of it. Yeah, so that's horizontal slicing. Of course, at each stage, you will learn that, God, I can't create this backend service because this integration with vendor's API, it's not really working. Yeah, and the same goes on front end. Yeah, there was last minute changes to designs, and well, API is no longer suitable or whatever. Yeah, it's a common experience when you use horizontal slicing. So the right approach that supports this practice of using high code coverage and this bulletproof development process is vertical slicing. So like first of all, you have integrations with external parties. There is a great risk. Well, they may be unstable, they may have undocumented features or bugs. Basically, you need to learn the stuff. So it makes sense, for example, to do some proof of concept to just have some bunch of scripts that give you information how do you actually use those APIs. Then you can deliver another slice with browsing offers from one vendor. Okay, so you can't buy anything, but at least you have all the critical bits in place. You have front end connected to back end, and they connect to the vendor's API. Yeah, so the integration problems are addressed from the day one. And then another slice would be to purchase on one vendor. Maybe fourth slide would be to add just another second vendor with a bit of refactoring in the middle, because probably you weren't able to make sense of all the right abstractions with just one vendor, and then adding more vendors as you go. Yeah. So the second skill is ATDD, and that's an acronym for Acceptance Test Driven Development. So well, it's an addition to a classical TDD cycle. When you write test, it fails, then you write the implementation, test starts to pass, and then you refactor one either test or implementation, never two at once, until you're happy. So ATDD means, okay, this cycle is fine. This is the circle on the right side of you, I guess, yeah. And it adds another loop on top of it. So you don't start with the small unit test, you start rather with some acceptance tests. And the acceptance test is something written from a perspective of a user, like to if it meets some business requirements. You will see an example in a second. And the third stuff is to focus not on implementation details, is to focus on observable results in tests. And this is easy when you start from an acceptance test perspective, because you're basically trying to figure out what will users see. And there are a bunch of heuristics that you could use to figure out what the test scenario might be. For example, when a user does this action I'm implementing, where they will see a result of this action. Will something change? I don't know, on the other endpoint, on the other screen? Maybe they will not see the result of their action, but maybe some other user do. Does this action affect other features? Maybe something will be now possible that previously wasn't, or maybe something was possible in the past, but after this action you maybe can't do anything. Yeah, so you're looking for this kind of stuff, and of course I will show an example, like I said. So going back to the application, I tried to cover in 100%. So you got on the left some database that application picked data from, and at the end it produced some files. So obviously, the arrange part of the test would be to put something in the database. Doesn't matter if it's a right idea to integrate via database. Well, it's out of this question right now, obviously not. Can you tell me what would be the observable result of this program working? What can I see from the outside? That this program will run, for example, one loop, and it did something. Yeah, okay, yeah, there are a couple of people in the room that are shouting files, thanks. Yeah, obviously, this could have been done better. If I started from such a high-level test, I could probably cover this nonsense property that I showed you before, yeah? Because probably it was used somewhere in the process. So coming to the development process with useful 100% code coverage, the process is as follows. At first, you pick up the task from the backlog or from a sprint or however you work. Maybe you figure out the task yourself. Maybe you're working Kanban. Doesn't matter. Well, you have a task at hand. You're thinking about acceptance test scenarios from a perspective of user, at least one. Okay? The more you can come up with, the better. But one is also fine because it's something you can start. Then you write a test for this scenario, or at least in some natural language what the scenario would be, implement the feature, and then check code coverage. Okay, and repeat the steps 2 to 5 until satisfied. And I will show you an example right now. So let's say we have a task that says the user story maybe. A customer can store their payment card. So we look at the process. Ensure, step 1, pick up a task and ensure it can be verified. Can this be verified? How?
If you have card storage, you can check that the card is in storage.
Okay. The question, okay, so the idea from the audience is there is certainly a storage if we are storing the card, right? And can we just consult the storage? Yeah. Okay. So the question is then, the follow-up question, is the storage like visible to the user, maybe some other users? Like, is it, you know, a black part of this black box I'm testing, or is it like, you know, visible somewhere? So in case it is, yeah, I could test on that, but I will not let you spoil this presentation. Let's assume it's not. It's an implementation detail. So alone, this task is unverifiable. If I assert it on the, for example, database table, I would couple my implementation to tests, and it's like, you know, jumping in concrete shoes to the ocean. You won't move out of this. Yeah. So if we want to focus on an observable behavior and get tests that will make refactoring possible, we need to find something that we can assert on. And this will depend on the project. Of course, I will use the simplest example. So once we store the card, well, we can later retrieve it. Yeah, so it's super simple. And yeah, so that's basically the test scenario could simply be derived from the task. And I like to, for example, at least at giving it a first shot, to write a test name that actually expresses that scenario, even before I write the code. Yeah, I already know what I will be testing under what circumstances. So the function is called like it spells on the screen, that test customer can read stored payment card details, and that's it. But that's only like, you know, for example, we are talking just theory, just, you know, testing in general. The same thing could be, you know, checked by a human, and then how to implement it. Let's assume like you have the simple two-layer architecture that, you know, you have some UI, some frontend, maybe single page application, maybe just HTML. You have a layer of API or view in Django, and then you have model, like a database model. Yeah. Where would you put this acceptance scenario implementation, given that you have such an architecture? Okay, so there is someone shy whispering UI. Okay, that's one idea. Yeah, okay. And someone else also very shy, so I couldn't track who said it. You're laughing. I got you. Said the UI, API. Okay, so the thing with UI is that from my experience at least, it's not very stable. The more tests you write on the UI, it becomes very brittle because they exercise all the stuff, and somehow these pesky front-end developers cannot get their shit right, and, you know, it's never working. Yeah, I'm not writing front-end, by the way. That's just joke. Okay. I mean, in a single page applications or in HTML general, I mean, it's just generally hard, yeah, because these applications are, well, dynamic, they have rendered components. It's difficult to get those tests right. They also will be slowing the entire test suite. So I usually do the way that another guy in the audience said. I put them at the API level, yeah. API would be pretty stable, because this is an integration point for, like, for example, for UI. So I will put it there. Of course, I can't put it in the model because it's, well, too low. Can't check this hypothesis on a model level. So a test would start like this. So I will be just adding the payment card, sending an HTTP request using this like test client, which should be built in your test framework. I will put an assert in the middle of a test to check if this operation succeeded, but beware, this is not the assertion that checks if the test passes. This is just to make sure that this step succeeded, okay? And then I will do the actual assertion. I will retrieve the card. Yeah, so that way I implement this test scenario. Yeah, so I will be testing on the level of API. It's my it's my conscious decision to make it on this level and check this requirement this way. And then we check coverage. Wow, 100%. Time for Counter-Strike. It's the easiest 100 you ever earned. Yeah, so now it's time to like the last step of the process. So we either look for most test scenarios, like and repeat adding their implementation. If we need to, refactor something, maybe remove some duplications, we can do it at one of these stages. But if this test actually satisfies us, I mean, in a way, like we are confident with going to production, that's it. Maybe your feature is such a simple thing that single test really covers it all. So the code coverage like shouldn't be actually your indicator whether you're good to go, but it should be like a hint to you to check is it okay now? Yeah, did I miss something? Should I add something more? And now a slow digression about verification methods. So when you think about it, when you like assertions in tests, when you verify some hypothesis, there are only 4 possible ways to do that. The first one is to check the returned result from a function or a method. And this is the thing that I did with the function that determined your queue position at the doctor's room. The second is the raised exception, or lack of it. Then we have a state verification. For example, you call one endpoint or one method of the object, and then you check another endpoint, another method, or another field to check if it returns whatever you expect. And the fourth way is with mocks. Yeah, there are no other ways. Which method I used in the test? Yeah, absolutely. Return value and state. Yeah. Okay, so there is an idea that both returned value and state. I would say the state. I mean, but I get why you answered like that. You got lost in the mechanics a bit. I mean, I'm testing really the application that has an API onto it, yeah. And the fact that those test client return result is like a mechanic of it. So this is a state verification, yeah, in particular.
So we're not counting return values as return values from API, just return values from function.
Yeah. So the comment from the audience was that we do not count returns from the API as a verification here, but we do this when we call a function, then we assert on that. Yep. Okay, so let's get to something more complicated. And an example that the customer's card is actually kept in an external system, because of course when we'll be doing like a production grade development, we wouldn't be storing payment card in our system because there are a lot of regulations like PSD2 and so on that basically just police would knock on your doors, or you will pay just a huge fine for doing so if you didn't met these regulations. So okay, so to do so, okay, so let's see how the endpoint in the application might look like. So the storing card in the external system might be just as simple as just sending them HTTP requests. Here, as you can see, example.tech that you can see at the top of the function body is actually like what we need, endpoint we need to call to store the card payment there. And we return with some response with status code. Okay, so the architecture gets a bit more complicated there. So we have this external system like we are integrating with, and the rest of our architecture remains untouched. In order to deal with the situation, I like to use, and I also recommend it, a gateway pattern. So this is the kind of a design pattern that provides just a layer of abstraction over the external system that you are integrating with. So I will just move the contents of the view to the gateway class, and well, let's call it payments gateway. And since I will not be able to call this external system in test because I know maybe I can't, maybe they don't have test API, or for whatever reason it's slow, it's unstable, doesn't matter. Then I would like to formalize this contract a bit more in order the type hints and MyPy, you know, will help me ensure correctness. We're gone. Out of time. Yep. Nie ma ekranu i nie ma... No. No. Nie? Już, dobra. So I shall continue in English, as it's it's strange to change language midway. So we were at the point when we had an integration with an external system, and I'd like to show you usage of a gateway design pattern. So we create a layer of abstraction over that external system to, you know, hide some details like communication protocol, because really it's not that important in a place where we implement this logic of communication. So we'll just move the code responsible for sending the HTTP request to the gateway class. In a way, it's hidden from its users. They no longer know there's an HTTP request underneath. And in order to formalize this contract a bit with the code that uses this payment gateway class, we'll introduce another design pattern. Maybe it's too big word for that, but we'll introduce DTO, which is data transfer object. So just a simple typed structure that, you know, is used for passing data around. And then in our test, we can make actually an assertion. This is now an interaction assertion. We can make an assertion that we actually called this gateway once with a DTO with a specific value. Yeah. So now the assertion is very strict. By the way, these helper functions you can see here, when or verify, are coming from Python Mockito library. That's a bit more, well, a lot more powerful than built-in mock, because, for example, it will verify that if you, for example, stub a non-existing function, or if you are like maybe passing the arguments of types that are not supported and so on. So it does a lot of additional checks to make sure that, you know, your tests stay up to date with the implementation, and also you're not doing anything stupid. Yeah, and then if we run a coverage with such a test, we'll get, well, not 100% coverage, because of course the gateway itself is not tested, right? But the acceptance tests, well, they do pass. So this is now a moment that, you know, we spend the time to actually test this test gateway separately, but in acceptance tests, we, you know, draw a line. An external system is something we can't control really. We still can't even think about testing in acceptance ways with it. So we draw a very distinct line between those two things. And well, we need to do it separately. And the question is, would it be safe? Yes, if you set MyPy or another type checker in a strict mode, that, you know, would be very tedious about any missing type annotations, or if you are misusing them. So because you have these type hints, it's a formal contract, and in a way, in places where you like can't use some parts of code in your test because maybe they're slow, maybe they're external systems you can't control, if you put a layer of abstraction there and put type hits around it, well, you have a pretty nice zone to, you know, to put your test around it. And there are more ways to leverage gateway pattern. For example, in tests, we can emulate the behavior of the external system, providing such a fake. So for example, we had such a project in one of the previous companies I worked for, that they had a test environment. Well, that's good. It didn't work. That's bad. So, for example, you could get a list of offers, but you couldn't buy any of them because it didn't work at all. And also, we expected such a behavior that after you like send the request to buy, they will, in a few seconds, hit you back with another request confirming that the transaction was okay, or it failed. Yeah. So our gateway, that was also running in a staging environment, was simulating that behavior. Yeah. So it accepted all the transactions except some of that we marked as failing on purpose, and it simulated that behavior was hitting us back with another request. Yeah. So this layer of abstraction has more like applications, and also we can not only, for example, abstract away these HTTP requests, but we can also, for example, see like which are the error situations that we would like to handle and return them maybe in a form of errors, maybe write some specific exceptions and so on. Like, for example, maybe their API returns the message that sorry, your order is incorrect because something, and we want to handle it, so we read it from the JSON or whatever they return and write a specific focus exception. All right. So to go to the testing strategy with 100% code coverage, so we start from the high level, from the acceptance tests. This gives us very high coverage from the beginning. It tests all these pesky, like stupid things like those property that I showed you in the beginning. You get very high coverage from the beginning. If it's a simple feature, you already at 100%. If it's a more complicated feature, like you have some complicated logic, maybe some calculator and so on, you can always add more specialized, more low-level tests on these lower levels. Introduce like more level of abstractions, use other patterns and so on. And still with 100% coverage doesn't mean you are completely safe. Michał during his presentation mentions, I catch you, you weren't listening. You had a head in your phone. Okay, yeah, okay, that's fine, keep going. Michał in his presentations mentions one of these cases that in the past he had an issue that, for example, okay, he had high coverage, he deployed the application to production and it didn't work. I also had such similar experiences, but I never claimed that code coverage would secure you from that. You need to supplement this quality assurance strategy with other types of tests or other types of verifications. There still may be need for some end-to-end tests that will go not through that UI, you know, to make sure that everything, every piece is in place and they can talk to each other. You can employ some synthetic monitoring if it makes sense. These are, well, continuous testing that run in production that simulates some behaviors of the real users. So for example, they register, set up an account, does something and so on. And they run in a loop, in a production and make sure, yeah, if everything works fine. For this particular issue that Michał mentioned, but I don't have this in slides because, well, I'm not a wizard and my crystal ball malfunctions recently. We, for example, use during the deployment liveness and readiness checks. So if the application is deployed but doesn't start up because something is wrong, we detect it and abort the deployment. Yeah, so the old version is still running, but we see that something is wrong. And another stuff that we have post-deployment tests, and these are like specific other tests that after the application is successfully deployed, we have like a status endpoint that we send requests to and check if it can connect, for example, to database and other downstream services. If it does, the deployment is fine. If not, the alarm is raised. And of course, sometimes you will have to put those pragma no cover commands or disabled in a config file because for two reasons. One of them is like places that will never be covered, like body of abstract method, because there is no implementation, there is just pass keyword. Or, for example, there are some bugs in coverage, and this also unfortunately happens. For example, with asynchronous context managers, asynchronous also iteration, sometimes they report coverage as missing, which is obviously not true, but the coverage PI is working on it and resolving those issues. And what in a case that if you tried to test in a high level on acceptance ones, but you ended up with tests that are very brittle, very long, and they're unmaintainable. So the problem is not in your testing strategy. The problem is in your architecture because it doesn't support this type of testing. And you're trying to test too many things at once. And the only remedy to that is to provide more modularization, divide code into smaller autonomous components. Think like maybe microservices, but they doesn't have to be microservices. They can also be like component in a single code base, like a modular monolith. This is one of the approaches. So you put your acceptance test on the level of these components. And well, in some of them, maybe you need to use some more sophisticated architecture, maybe use some additional layers of abstraction, additional design patterns. For example, component B has not only API layer, but they have also service layer, so some additional classes or functions that does some business logic. Maybe you would like to use repository there because of reasons. So you still have a way to adjust your architecture to your needs. Whatever would be more like convenient for testing. And of course, in this acceptance test, I test with database because it's not a big deal unless you're in the cloud. But that, well, it's your fault. If you have like database like PostgreSQL or whatever can be set up locally, then you should be good to go. And also the code coverage tools are not that demanding because all we can have is actually this branch coverage. If we can cover, all the paths in the code, they don't even check the combinations of it. It's not really that demanding. And to quickly conclude, well, the code coverage should be your compass rather, show you the direction where you should head next. And on its own, it doesn't guarantee, that your program will work in production, because also we're only testing cases we thought of, and even if 100% coverage, we're never sure. So giving that moment after reaching 100% code coverage, or if you don't have that level is unachievable for some reason, using a moment to reflect. Did I check all the cases? Is it fine? Maybe talking to someone else on the team to come up with another scenarios is an opportunity, to just improve the quality of your code. And of course, you never be able to cover all the cases. So there are a lot of tools that can increase the coverage. For example, there is mutation testing that introduces random changes in your code. For example, changes equal sign to greater to, and checks if tests still pass. If they do, you're not testing extensively. There is a technique called property-based testing, by the way, which is also advertised as, oh, never write your tests again on your own. I just wait for a group of disappointed people in the future that would be tricked by this naive marketing. Of course, monitoring in production, then type hints and checkers. Checkers are indispensable if you use type hints, otherwise you're fooling yourself. Type hints are just the comments. If nothing is verifying them, nothing prevents them from getting outdated. That code coverage, but the most important last is the development process as a whole. Are you able to deploy to production often? Are you doing your tasks in short cycles using vertical slices? If not, there's a lot to catch up. For some further reading, I have a couple of links, so the slides will be shared, I guess, in a comment on meetup.com. So check it from time to time. I don't know if guys are also sharing slides on pykonik.org site. Yeah, okay, so you will also be able to find there. By the way, the second link doesn't work. It was my blog, but the cloud company that moved servers of their clients into cloud without their consent recently had a bug that prevented me from prolonging the VPS, so it's gone. But check in some time. I promise it will be back. Yeah, so I guess there's supposed to be time for questions, but I am not sure if we have any left. 2 minutes. 2 minutes. Right.
Hello? Oh, okay. Yeah. So basically, as a QA, I think we can have a long discussion later in a bar and maybe a fist fight. But generally, two comments or questions. You said that we should slice vertically, right, instead of horizontally. But then, when it comes to the testing, to the acceptance testing, you said, okay, forget about the UI. We shouldn't test this UI. Just focus on the UI. So why is that? Why we leave that? Because from my perspective, I know that UI is the hard part, and it's long and flaky and all of that. But in case of just storing data, okay, we don't need to go to full end-to-end path, but we can have this UI for putting data of a card, for example, and then only read it from API that it's saved, right? So just to not create another functionality of displaying and everything. So that's one of my questions. Why you cut like that on the API? And the second question is.
Can we first answer the first one? I think it will be simpler. By the way, that's why I got rid of testers in my team. No, that's a joke, obviously, but on the serious note, we, for example, have a team that doesn't have testers on the team. Every developer is responsible for the development. That's just the comment for the context, not the personal attack. Yeah, by the way, thanks for the question. Yeah. Thanks for the question, by the way. So I tried to rephrase the question, okay, to make sure that I understood it right. Otherwise, we're left at the bar discussions. So you're asking like why I do this hard cut and the API level, right? And not
Yeah, when we cut vertically, so basically we would like to check the
Yeah.
whole story, would say,
Yeah.
from the user perspective, but you cut on the API.
Yeah. Yeah. So the thing is that our automated test acceptance ones are living with the in the code repository that's there. Yeah. The UI is separate project that's like lives elsewhere. It's like also a common ground for a couple of teams. In the past, it was maybe a single team, but nonetheless, it's much easier to to maintain them and also run those tests at the same time. It's just this setup is pretty similar to what Michał showed in the first presentation. We could set up all these services and databases and other stuff locally, and it's just easier. Of course, I said about this vertical slicing, but it doesn't mean that since these are separate repositories, we're still not able to deliver them like as a vertical slice. First thing that gets deployed and tested is this part, yeah, API. So it's a bit of mix of the horizontal slicing with vertical slicing, but at least we have our acceptance testing there, yeah.
Okay, so I just missing the context too.
Yeah, absolutely.
Then,
But
okay,
that's
so,
fair.
So that's clear. So the other one is that starting with the acceptance and writing the stuff that you showed, it looks more like we are focused on the on this golden path, and okay, so let's check if everything is ready, but if not, then okay, that's fail, and that's all. So shouldn't we just focus more on the what happened if something bad happens?
Shouldn't we
So
talk more about
errors, validation?
unhappy?
Yep.
Yeah, definitely. I mean, that's a skill that personally think a lot of developers are lacking, and the testers are really proficient at this, meaning just looking for the pessimistic scenarios, yes? No, I mean it's true. It's honest, yeah? If we have another person on our team, like for example, like I said, I don't have a tester on my team, but sometimes we like do just pairing, I mean, a group of developers, to to the other person, like to be that bad guy that will think more about these bad test scenarios. That's also why I use this 100% test coverage for a moment of reflection, for like being mindful about this. Okay, I got this happy path. I can stop focusing on the making it right, and now let's think about what might go wrong. Yeah, if I'm able to figure out some pessimistic scenarios before, that's better. But that's a skill, I think. Yeah, that's a different mindset, and it may be difficult to just switch. So yeah, that's one of the reasons I would personally like to have one tester on my team. No, to just be able to pair on the test scenarios. Yeah.
Okay, unfortunately, we don't have time for other questions, so we need to move them to Infusia, all the questions. So once again, thanks a lot for these presentations to Sebastian.
Thanks.
And we're immediately moving to the lightning talk sections. So Dominic will start first because he's very eager to do a lightning talk. And I would And since Dominic is setting up everything, I think he's pretty close. We will have 5 lightning talks. Unfortunately, due to the electricity downtime, we don't have really time for much more, but I always encourage to bring your laptop to Infusia and show something interesting there. There will be plenty of time for that. And now I'm passing the microphone to Dominic.
It's better. So raise your hand if you saw this tweet that was like tweeted like 2 or 3 days ago. Okay, no, one person. Cool. So this tweet is about Python 3.8. Actually, whatever we have here actually also works in 3.11 and 3.10 and 3.9. So let's see what it does. So we have this weird Python code, and if I show you that I have this code here, I have of course the comment and then this code. And so if I run it, it will tell me hacked lol. Yeah. So what is going on in here? Let's maybe rewrite this so to make it a bit more clear what is going on. It's called c.py. Okay, so we have plenty of things here, but we have first of all this unused. This is an unused variable. It's never used anywhere in this code. It has some bullshit weird content. But then we have this imports runpy and pycompile. I have refactored this code a little bit to make it like more clear what's going on. So it's not like so compacted and so on. Then we have this print file because then we compile the file that we are currently in. And then we will actually print the source here, which is the result of the compile because this, maybe we won't print it first, maybe we'll just run it first. And this is what the code does, right? And I can show you that if we do Python 3 cpy, it will again tell me hacked lol. So what the hell is going on in here? We are basically using some standard libraries called runpy and pycompile. So we are compiling the same file, supposedly, because this __ file says it's cpy. And then we are supposedly executing the same file, but something weird is happening. So let's see what will happen if we try to print the source. If we try to print the source, it will tell us that the source is actually located somewhere else because it was compiled to the PYC file. And there are some decompilers for PYC files, which I obviously doesn't have installed here. So I'll try to install it very fast. It should be -m first of all, and then uncompile. Yeah, but in the meantime, let's look again at this co.py file. Am I not on the server? I am on the server, but not in a wrong directory. But we have it installed already back. So now we can do something like, we can see what's in pycache, and we can do uncompile 6 and this pycache c.cpython, right? If we uncompile this code, basically we decompile the PYC file back to the Python sources, we can see that this is pretty much the same code as we had before. So what else can we do to inspect what is happening here? Well, we can use a debugger, right? And like basically run this code under a debugger and try to debug it. I used IPDB before, but I have found this fancy PUDB 2 minutes ago, so I will use it instead. This PUDB is so fancy that it is actually showing up as a terminal, but maybe I'll restart it so that we have a bit better view. I have no idea why this variable on the right side says that the IPDB is like it's actually correct. It says this is a module, right? But we are paused on the run path line. So if we step inside into it, this is a standard library. This runpy, it has this runpy function. If we continue this further, there are some like if conditions, some weird things. Okay, here's an interesting thing. Here's an importer, which is trying to find an importer for this path name, and this path name is this PYC file. We can see that in the variables, right? So we got a zip importer, and now what else are we doing further here? If we continue this further, here's some syspath insert. And for those who doesn't know, you can actually import Python files from zip files. And whether this is happening here, we'll see in a moment. But basically, we are adding some path insert, which is this path name. So this PYC is added to the path. Then we are getting into try. We are getting some get main module details. And afterwards, we already have a code object here. A code object is, something that is there for every function in or every module in the Python. So if we get to a console here on the bottom of the screen, I hope you can see it here. There is a console and I can type stuff here. So for example, I can import this, and this module can be used for disassembling stuff. And one thing that you can disassemble is strings with source code, but the other thing is those code objects. So if I decompile this code object, now it's troublesome because I have no idea how to actually, there are only two instructions here. As you can see, there is this load name print and load const hacked lol. So I don't even have to scroll it up because there are only two instructions, luckily. After the module was imported supposedly as a zip file, something happened that we can actually see that there are just two instructions in this module. So what else can we do here? Maybe instead of trying to debug it, we can try to take this C Python file, put it into an IPython session, import zip file, use zip file to try to see if we can take this PYC file and maybe read it as a zip file. This actually works. It's actually surprising to me, but okay, it works. But why does this work actually? Because this is not a real zip file. This is a PYC file, supposedly. I'm wondering what will happen if I do file on it. It will say just data. It's it's data because it is a compiled Python bytecode. If you do XXD on it, it's you can see the bytes here, and maybe they do not say anything to you, but basically this is still a PYC file, but Python can interpret it as a zip file. The question is why? And the answer is because there is this weird unused string. I mean, it's a byte string because it starts with B, right? And even though it's unused, when this is compiled to a PYC file, this data that is in this byte string here, it has to be embedded somewhere in this PYC file, right? And the question now is, how do you open zip files generally? How do you treat zip files? So for those who doesn't know, there is this guy called Korkami who does like file formats analysis, and it has this PIX repository where he shows how, for example, a zip file looks like. And maybe this is not so easy to read, but generally we read zip files from the end, and we look for a thing called end of central directory, and this end of central directory has to have this like PK 5 and 6 bytes at somewhere like at the beginning of this end. So here it is. But if we look over this PYC file, we don't see this PK here at the end. We can see PK, for example, here. We can see PK here and here. So, this embedded string is probably somewhere here because this PK was there in this embedded string. So the question now is, Python treats this as a zip file. The question is, will a normal tool that, can unzip zip files treat it as a zip file if I do this and do unzip on this? Well, it says, it actually can. It's interesting. I didn't know. And now if we try to print this, it doesn't work here, right? I mean, it basically took our zip file and there's nothing in it. So clearly, someone is lying here and misunderstanding some file formats. Like I tried to unzip this with unzip, like GNU unzip or whatever the tool was used. Actually, I'm not sure under the hood. Or Python is treating this PYC file incorrectly. And if you even look at, well, we can actually do one more test. We did this test here. So we could even try to, unzip this file here, but I don't have time for it probably. So let me show you something else. We will go to the zip import.py file, and this is the library that is used by Python whenever you are trying to import something from a zip file. And we could see in this debugger that there was this zip file importer. So it means that at some point, Python decided that this file is a zip file somehow. And if I scroll to a proper invocation here, and this is the one, maybe this is not, actually this is the one, but it's not so obvious. We can start with init of the zip importer, because what happens under the hood with Python, it tries different importers. Yeah, but basically, if you want to understand this deeper, you can look it up yourself. Thank you. Because we don't have time, right?
Chciałem to delikatnie i powoli zacząć dawać znać, że się czas kończy, ale no,
Mogłeś powiedzieć przez mikrofon.
nie byłoby słychać. Nie, to wiesz, zazwyczaj się robi tak, że powolutku zaczyna się bić brawo, tylko ktoś potwierdził, więc sorry, że tak wyszło. Tak, proszę?
Okay. Hi, hello. How many of you use GitHub Copilot? 1, 2, 3, 4, 5. Okay. What about the rest of you? Do you write code? Yeah. Do you write any code for anything? Okay. How many of you heard about GitHub Copilot? Okay, that's better. How many of you heard about OpenAI and GPT-3 and stuff like that? Oh, yeah, of course, everyone. Why don't you use GitHub Copilot? Oh my God. So what's that? A brief story. We started with these, little weird things when we used to craft some text on that, right? Then we evolved to use V, but there is no logo for V, so I use Vim. And then, what? Yeah, I know. Yeah, exactly. That's why I'm showing you this one. Who recognized this third icon? Eclipse. Yes. What? Yes. Yes, exactly. And we need to move on. So that's why GitHub Copilot is here. So what is doing that? So basically, it's something very little strange, created by GitHub that uses OpenAI, that uses Codex. So basically, when you go and want some code, and you're going on a chat GPT or OpenAI chat and things like that, and you're asking, oh my God, write me some stuff and write me a simple piece of code, don't do that. You have GitHub Copilot. So you have something that connects IDE, OpenAI, and Stack Overflow in one place. You don't need to go everywhere. You don't need to waste your time. Start using GitHub Copilot. Guys, it's really helping you. Don't go to OpenAI. That doesn't matter. No, I hate Microsoft. No, I hate Microsoft. I just want to tell you, because everyone is talking about OpenAI. Oh my God, it's so awesome. And yeah, we need to use chat to get some text, but it doesn't. It's wasting your time. Be efficient. So here's how it looks like. This is example from my code. So for example, I wrote this test on the very beginning, and then it just tells me, okay, now write test for encoder passphrase. Hey, cool, I will do that. Okay, so I created a function called fill in password. Okay, and it gives me all the information I need, all the code I need for the fill in password. Awesome. I hate regex. I never know how to write cool regex. Okay, so I just put comment here. Just create a regex that matches letters and numbers only. That's all. Okay, I don't want to create another dumb random string, because I don't import a package or something. Just write it. Yep, that's here. So don't need to go on a website. Don't need to look for the Stack Overflow. You're just installing the GitHub Copilot, the plugin for example, for VS Code, and yep, that's only the advantage. $10 a month. But you get faster code, you get better code, you get cleaner code. Of course, it doesn't give you, Yeah, sure. It's JavaScript. Yeah, because I didn't introduce myself. Yeah, I'm a QA and I'm writing JavaScript. Yeah. And yeah, of course, it has these advantages. It doesn't. It's not 100% precise. It's not. You always need to care about it. You need to look at and find. What's wrong, and you need to correct it. But you don't need to write the code by yourself. You just okay, a little tweak here, a little tweak there. So faster, better, cleaner. $10 a month. It's expensive. Yes, expensive. Okay, so doesn't care. You're paying for these flat or even carved screens. Paying a lot of bucks and a very comfortable chair. The chair to not to hurt your back. You're paying a lot, and for RGB lights on your computer, you're paying for that. It's $10 a month just to make you faster, better, and you can spend the rest of the time, playing Counter-Strike, for example. So wake up, guys! The future is now. Thank you.
Hello. I wanted to talk about attribute descriptors. I know they're profusely used in Python. I'm not sure how all of you are familiar with them. So by a raise of hand, could you tell me how many of you know what those are and how they work? Okay, I think we, yeah, I think it's, I was a bit afraid that I'm gonna tell obvious things, but yeah, sure. So how it all started to me, I came to Python from Java, and the self kind of bugged me. How the hell did the self got there? What are we writing? Is it a method? Is it a pure function? Because we get everything as an attribute. What's parameter? What's going on? And well, I didn't translate this string. I wrote it in English. Don't mind me. So what? Let's do a little bit of test. Oh yeah, sorry. Is that better? Great. So, oh no. Wow. I mean, I'm a bit old, but not that old. Yeah, right. So let's create some class. Let's create some method. And let's, oh, of course, self. Sorry, that's here. And let's see what's going on. Like, is a.f, what is it? Is a function. Okay. It's the same thing as a dict f, right? Okay. But what is an f on an instance? And we see that it's something completely different. When we do the is, it's of course false, because those are different objects. And another thing, let's check the other one. It's also false. So what does it mean? It means that every time we call, we get the method, we actually don't get our function, we get something different. And every time we do that, we get something new, or at least different. So what's going on in here? They at least, well, I would expect so, to be the same thing. Well, okay, I think we're short of time, so I'm gonna skip those two, but they behave pretty similarly. So what am I talking about? I'm talking about descriptor protocol. I'm talking about attribute descriptors. And oh, I'm sorry, I'm gonna make it full screen. Yeah. So it's basically an ability in Python to customize how the access to the property is. What happens when we access a property? We use a special method underscore get underscore, and we can do well, a lot of cool stuff with this. It basically binds the, let's say, functional side, that is functions with data in our class. So what we could do, I created a short example. Sorry. What's this called? Yeah. So this is the speed descriptor. It basically implements all the methods that descriptor gets. And when we do something like this, I can now create a class. Let's say speed. That will be speed. And it expects a speed limit here as an argument. So I'll give like 100, let's say. Okay, and first thing we see is that setName method was called, so our descriptor will know what the attribute, it's at the very end here, what the name, what attribute it is assigned to. What we can do, we can set this value, so let's say speed równa się, equals, sorry. Yeah, it's a bit tricky. Okay, we can assign it, we can get it. Sorry, I assigned to a class, not to an instance. Yeah, so I messed it up. Okay, let's do it again. Sorry. I overwrite the speed property. I could have, yeah. Sorry. That's how it goes. Let's do 100. Yeah. So we can get an instance, we can an instance, right? Yeah, speed. Jesus Christ. Okay, and we see the set method was called, so we can customize the way the value is set. We can get the value. Oh, my setter validates whether we like, well, if I am going too fast. So all this cool stuff are possible with this. What it has to the method? Well, to the method on the instance of the objects. Well, actually, functions are descriptors. So what we can do, we can create any function like this, and we can check it. Well, the descriptor is set on the class, so we have to do the type of f, and we can access, like, I don't know, the get, for example, right? And it's 1 underscore too far. Yeah. So functions, all of them have those descriptor protocol methods. Okay. Yeah, I'm supposed. So yeah, summing it up. Thank you.
Ej, stream dalej jest.
Na którymś Europythonie w przyszłości lub macie bilety na tego Europythona, to możecie brać udział w głosowaniu i wyrazić swoje preferencje na temat tego, co chcielibyście zobaczyć na konferencji. Wszystkie propozale, które zostały wysłane, są dostępne, więc można je tam przeczytać, całe tytuły, abstrakty i zagłosować, czy chcecie je zobaczyć, czy nie. I to chyba tyle. Bilety też są dostępne. O, jeżeli ktoś jest zainteresowany biletami na EuroPython, to mamy specjalną zniżkę dla Pykonika, więc na afterze mogę się z wami podzielić tą zniżką. I to chyba tyle z mojej strony.
Hej. Tak, jako że jednak nasz projektor jeszcze działa, to sorry, as our projector still works, a quick lightning talk from me. So, do you remember my last presentation? Not the lightning talk, the presentation about PyProject.com. Some of you may remember. So, I didn't answer one question. Oh, sorry. Okay. Yeah, one question. Which one to choose? Which one is the best? So here's the answer for you. So there's no real answer for that. Sorry to disappoint you. You have to choose your own poison. If you really want some advice, here's the quick summary, which one is better for what. And that's all from me. Thank you.
Spoko, bo już wszystkie leki. Dobra. Masz? No to. A masz podpinaczkę z czymś, czy po prostu chcesz powiedzieć?
Nie, po prostu powiem. Dobra. Może być po polsku już? Myślę, że będzie. No trudno. Mogę powtórzyć po angielsku potem. Dobra, to chciałem powiedzieć o takim małym fenomenie, który występuje i sporo osób chyba go ma, bo słyszałem dzisiaj parę razy o tym na tej sali. Tak zwana klątwa wiedzy. Czy ktoś wie, co to jest? Dobra, jedna osoba wie. Proszę? No, nie, to nie w tą stronę. Zła odpowiedź. No, nawet nie. Wiecie co? Chodzi o to, że z 2 razy to dzisiaj słyszałem, że nawet ludzie, którzy tu wychodzą i opowiadają, mają taki strach, że to, co powiedzą, kurde, przecież to jest oczywiste. Przecież ta reszta niczego się nie dowie, nie wiem, wyśmieje się, znudzi się, wyjdzie, cokolwiek zrobi. Właśnie wcale tak nie jest, nie? Nie porównujcie się, nie wiem, na przykład do Dominika. Ja zrozumiałem z jego prezentacji tylko słowo Python. Reszta była nowa i ogólnie dobrze się tego słucha, jest ciekawe, nie? Także wiecie, nie o to chodzi tutaj, żeby... Nie przychodźcie, znaczy, jeśli chcielibyście kiedyś, nie wiem, właśnie wziąć udział w prezentacji, powiedzieć coś, to wybierzcie po prostu coś, co fajnego, co zrobiliście i gwarantuję wam, że na sali znajdą się ludzie, którzy tego nie wiedzą i o tym nie słyszeli, nie? Ta klątwa wiedzy polega na tym, że właśnie kiedy poznacie jakąś informację, to wam się wydaje, że nagle dla wszystkich to jest oczywiste, bo wy tą wiedzę tam zinternalizowaliście, mówiąc po polskawemu i jasne, nie? Wszyscy o tym wiedzą. Wcale tak nie jest, nie? I to działa też w drugą stronę. Jak ja robię prezentację na jakiś taki temat zaawansowany, albo Dominik pewnie jak robi na jakąś prezentację na temat zaawansowany, to mu się wydaje, że dużo z tych rzeczy, które on pomija, bo dla niego są detalami, to wszyscy wiedzą, nie? Przez co jego prezentacja na przykład, albo moja, może być trudna w odbiorze, nie? I teraz mam takie pytanie z ciekawości. Ile osób na przykład podczas mojej prezentacji miało takie wrażenie, nie rozumiem, nie? Za duży skrót myślowy. Miał ktoś takie wrażenie? No, dobra. Słuchajcie, jeśli jest to szczere, to dziękuję, bo to znaczy, że robię dobrą robotę, ale wiecie, prezentacje są, czy występowanie na meetupach, czy branie udziału w społeczności są, wiecie, o fanie, nie? Chodzi o to, żeby podzielić się czymś ciekawym i gwarantuję wam, że na widowni znajdziecie ktoś, dla kogo będzie to coś nowego, nie? Michał pokazał mi dzisiaj parę fajnych sztuczek w Makefile'ach. Prezentację Dominika będę musiał obejrzeć jeszcze raz, ale to jest to po prostu, wiecie, ekspertyza w inną stronę, nie? Także taki krótki ode mnie. Dzięki.
Okay, so last few words before we disconnect the streaming. I wanted to thanks to everyone who was watching us on YouTube, including the people who were watching us on YouTube in this room when we had no electricity for 10 minutes. But thanks everyone who were watching us and hope to see you in a month. A teraz już przejdę do zakończenia spotkania po polsku, żeby było